And let's have our first speaker, Juming Tang, telling us more about the opportunities in food. Thank you.
Good morning. Good to see you, and thank you, Elise, to invite me over here. So I'd like to start. I changed the title a bit. Add opportunity and challenges for AI in food, and I'm from University of Washington. So I can tell you who I am, why I'm here, and what's expected to learn from this group. I had a mechanical engineering background, a bachelor's degree, and then went to agriculture and food engineering. And then I was assistant professor in food science and nutritional program in Canada and moved to our Washington State University and was there for about 29 years. I was a NASA fellow in the summertime in Jiang. There's the Mars mission for packaging. And then I was the chair of the department, and at that time we started this dialogue about AI. I think the discussion was initiated by IEEE. There's a new food engineering division, and then they approached American Society of Agricultural Engineers. So we had a meeting at East Lansing, about 150 people from industry, from academic, and then we moved our discussion to Boston at a meeting. So that was the time we get interested in AI and blockchain and Industry 4.0 was the discussion at the time. So once I come back, I talked to my vice president of Washington State. We did a plan for AI, and I formed a group to apply for grants, and we failed Washington State. And the reason for that is we didn't have a computer scientist to lead that. So next time we recruit scientists from computer scientists, and then Washington State gives us AI as your sister programs. So congratulations for you to get a big grant, and it's a great success. So I was elected to National Academy of 2021. I want to share with you about my plan for bringing AI to for food in the National Academy in the future. I can discuss with you how we do that. So I was elected to the National Academy of Inventors because we brought technology from TRL1 to TRL9. TRL9 is industrial implementation, goes through all these layers and steps, regulatory approval, involve about over 100 scientists, engineers, and many companies, including Mars. So long journey. I wish we have AI at the time that we can show the time from 15 years to maybe to 5 years. Now I joined University of Washington about a year ago, and as a chair of the Industrial Assistant Engineering, 70% of our faculties talk about AI, digital trends, using AI for different industry. And some of our faculty is Amazon scientists working in Amazon Scientific Center to do the last mile logistics. I also consulted for McCormick and also Pepsi. I'm still doing some consulting for them. So that's really the background. Our lab supported many companies. You can see this, those companies, all companies you may find their name and their product in the grocery stores. They flew over to Washington State, and then they used our pilot plan to study the performance of our technology. A lot of travel. Sometimes a company fly jet. I don't know if you've been to Pullman. It's a very small place, very hard to get. So companies sometimes fly the jet to park in Pullman. So a lot of our interactions and a lot of learning. I wish we have AI to help us to bring this technology to their place instead of coming to us. This is to talk about the technology we developed at Washington State. So my vision is to, I'm talking to a lot of companies, I've been consulting for them. Big company we talked last night, big company are very rigid. And and also if you look at this supply chain from the crop to the refinery ingredients to the large production lines, millions of products, and the product is very rigid. So I think we talked about circular economy a couple of years ago, and really we need to somehow. That's my vision, is to reduce this circularity and then reduce the waste through the chains. And so this is my vision, is to bring the technology to the local farmers and the groups so that we can actually utilize the knowledge and know-how to produce product for consumers. So that's my vision. So while we're here, we're here to shake hands with an AI expert as a food scientist. So AI has been, so I talk about food industry a little bit, so a lot of people knows about industry, but not all. Food industry starts from the agriculture to production. I should add extrusion there, as a unit operation to convert ingredients to high-value product. So if you look at the value of farm gate, it's about $1.16 trillion. This is 2021. And then you move through the production lines and then to the grocery store and consumers. So you talk about 8% of the GDP. So it's a large industry. And we employ about 22 million people in there. But if you look at so about 11% of people employed in the US, the services, production, and operations. But if you look at GDP and per person, it's very low because they are not paying very high wages. So number one issues with food at this time is the safety. If your company get a recourse, the company has to shut down because this is a new Modernization Food Act, and until you prove to them that your plant is being sanitized. So one example is the baby formula. About 3 years ago, the whole market was short of baby formulas because of one plant was shut down, and FDA asked the company to provide evidence to reopen it. So it's very tough to validate a plant. So food safety is a major issue. I have some problem with my, okay. So this is some kind of issues here is, a long supply chain. One company in Washington have a frozen product contaminated by listeria and in the 350 consumer products sold under 42 brands. So if one company has a contaminated products, this is what we call co-packers, or maybe a raw material production plant, and then you can distribute to different sites. So that's the one problem. And also, I showed this slides to Peter, and they say, everybody recognize this place? This is where we are now today here. So this is a virus, this is the issue. Fresh produce is a major problem. I know eating industry working on the fresh produce because there's no much thermal processing or other in between. So it's very tough to deal with. And norovirus is a major issue. This is 2017, and 1,000 people get sick, including students using this. Okay, I have a problem with my, should I point to a different place? So we need an effective detection and methods, predictive model for bacterial and viral pathogen in agricultural produce. So if you look at the thermal processing in the industry, we say, okay, 12 log reduction, 5 log reduction, but we don't really know how much log it is in the raw material. Do we really need that? So you talk to the thermal specialists, they told me, Juming Tang, Dr. Tang, we don't need 12 log reduction for some products. But we don't really know what's to come in the raw material, therefore we are very safe in having this 12 log reduction there. Food waste is another issue. I was talking to one person in the bus, and there's a lot of food waste generated, even through all this production, distribution, and consumers. And we're talking about 30% food are wasted, and then the loss about 1.3% of the total GDP. And those food waste are ending mostly in the landfills. And those create problems, not only the use the land, but also the microplastics come with the packaging contaminate the water and soil. And those food waste is very high value products actually. So we need a shelf life extension methods to using novel technology. We need new sensors. Thank you. This is much better, I hope. And then new AI platforms for logistics supply, because a lot of products are perishable. and you want to make sure that the supply chain is going to be transparent, so that we know where the problem is, if there's a short shelf life, and also about 2 or 3 years ago, NIST, National Institute of Standard and Technology, had 3 days of workshop specifically about food waste. The reason they talk about food waste is because a lot of products have this shelf life labeling. Nobody really understands what it means. Best used to buy, and there's no clear indication of remaining shelf life when you purchase it. EPA had this guidance October 2023 that discourage the use of landfill and even digestions. So you can send your product to the digester in agricultural farm, but then this digested material is spread on the field, then you still bring the microplastics into the field. So they really want to encourage upcycling. Again, talk about upcycling, kind of small this centers using data is a really good idea. I also have a new biodegradable packaging materials, and AI can play a role in there to develop a new packaging. So recently we have this Amazon project that we started basically to consider develop a new AI-driven platform that we can add sensors to the package, and then as part of a QR code, and so that we can actually, when people scan the product at the places where they receive it, hopefully this the QR code plus the indicator can transmit it to a platform. So that's the idea we try to pitch to Amazon, and Amazon really liked the idea. So we are now working with Tsukuba University with their AI and scientists. This is a cross-Pacific kind of initiative. This is only starting point. I was talking to Elise that I really like to see this as a starting platform, and I'm bringing the player here, and then we can reach out to Walmart Foundation or other places to get more funding to move this platform, and eventually that distributors, small and large, are going to have a transparent kind of cloud-based platform to manage their products. So I was telling a story yesterday that Amazon fly their products to Alaska, for example. Okay, the plane has to fly back. What do? They don't really fly back empty, so they bring their product back from the Alaska. The same thing. You fly ship to one place, and then you bring product back. Sometimes you bring agriculture product back, and so Amazon is very keen on understanding what's the shelf life of the product, and sometimes use 1-day delivery, sometimes use 3 days of truck. So this is really has implication about cost and quality. So that's why Amazon is very interesting. So we're promoting a collaboration between domain experts like us and AI experts like Alice and all you in the room. So this is kind of example of how we collaborate. This is called this is a $50 million initiative supported by Amazon and NVIDIA to University of Washington to work with Tsukuba University in Japan. Another issue is the labor cost. Washington State happens to be one of the highest salary paid state, and California is not far behind. Of course, DC is highest. So we are paying a lot of people for the labors. Then we have to look at how to use automation to increase the productivity and efficiency. So automation, and today we talk about automation has been used in the industry, food industry, a long time ago, about how we can speed that adaptation of this automation, and how we can use human robots in food services. I was talking to a manager of 13 restaurants in Seattle. He said, Jimmy, managing those clients services is very difficult because labor cost consisting of the recipes across these restaurants, and this is AI can help with trained chefs, right? So my wife was cooking something last night, the night before, and she was watching the YouTube, and she's preparing her meals, right, watching the YouTubes. So those tools can be very helpful for the restaurant managers. And so I just want to show one example. People forget about AI AI or automation has been used in industry many years ago. And there's a company called clean technology that developed those kind of automatic color sorting, and then carrots was cut into pieces, and then this machine is so fast moving this product, and then they use a vision system and use an air jet to pop out those green pieces, so they can replace about 20 people on one to pick up. And this is the newest invention they have. They have a vision system on the top and the bottom. This is for pre-freezing, for canning or others. So fresh produce clean up, goes through this machine, and then you sort out all these other foreign objects before going to the processing lines. Automation is used in that industry, but I think we hope to move into robots. I think yesterday or the day before yesterday, there was a news about Figure 03. I don't know if people look at Figure 03. They talk about promise of producing a humanoid robots and sell at $20,000 per person. So you can buy this. My mother say when she gets one help, she's going to purchase some of the humanoid robots. I think probably in a couple of years, $20,000 we can afford to do that. But this can be very versatile, flexible in service industry. You prepare meals, but you need training. You need AI training. You cannot really use program to train them. So we nice to have AI training with some kind of motion movement by trainers, and then machine can learn. So fourth issue is human health. So you can see the US is very, we are in trouble because of you can see the increase of obesity and weight along the time. And there's a recent article by University of Washington faculty published in Lancet. I can have time for this. So this article was published every 10 years, and this is a Lancet published 2019. The major issue of the food in the US and around the world is the lack of diet in whole grains. So how are you going to replace other refined ingredients with whole grain? That's going to totally change the operations. So again, there's a lot of role AI can play. So reformulated products based on whole grains and whole plant-based proteins, you have to adjust and develop new operations for large-scale operation. And also, what we find out is, QRs, those are very good whole grains, but in Pacific Northwest, there's no logistics supply. Those beans and farmers, really the beans does not accept those. So you need a logistics supply chain to specific for those whole grains, specific for the end products. So this is one of the projects we did, supported by USDA, $10 million grant, and we were about 3 years, and then we got another $15 million from our research foundation. This is whole grain meals, and we don't have expertise to develop that, and so we have to rely on people who know the formulations. So if we had AI to help us to develop this, I'm not talking about researchers, but also talk about the companies who really want to develop whole grain meals that bring to the consumers. Because at homes, I don't know many people. 2 minutes, okay. So those are the issues that we're facing here, and I have 2 minutes. I got I think this controller. So I'm going to skip this. Where are we going to go? I wish I have a faster movie. It's just stuck in there. Sorry. Where is this actually point to? I think that there should be.
It's right in the back. So
okay.
We have an even longer one, so we hope that will work.
Thank you.
better range. Can you try?
Yeah. Okay, this is much faster. So yeah, AI is going so fast. And then if we talk about 5 years ago, people may not be talking about AI at all. And because ChatGPT 2023, and then now you have this super agent that we can use to develop slides and others. And then you have those agent developer platform, NAN, and then there's Google AI and Kit. But food companies still resistant. Yesterday we talked about consumer food industry, transparency, data security, and cybersecurity, and then at the bottom is some companies still suspicious and skeptical about this, and models have not been validated. So hope that we are going to work together in the future. But anyway, what we will learn from this? I just put this 4 questions. What's the status for AI R&D related to food processing? What are low-hanging fruits and the long-term vision for AI? And how should food engineers, this is very important for us to work with you, and then how to improve university curriculums so that our next generation can learn more about and learn about AIs. So we are actually, from ChatGPT in 2023, I think MCP come this year, early this year, last year. So we can actually build an agent, and then not only on the cloud, but also edge AI can have a computer interface, the local devices, and control the hardware stuff. So my hope is that in the future we're going to have many, many different agents that work together. So that's my hope, and each of us can work on this. Another thing I want to mention about it, I just come back from National Academy of Engineering, and then there's a big title is of our future with artificial intelligence, opportunity and the risk. So what's the guardrails, what kind of risk we're going to face? I was talking to Elliot yesterday that Paul Singh was talking to me about writing a special issues for Bridge. This Bridge is an article, magazine published quarterly by the National Academy to educate the policymakers and others about big issues. So I was thinking about maybe, I'm talking to the editors, a team in DC, and their schedule is lined up for 2026, different industry. So this is I have a copy here if you want to look at. So I hope that Ali and somebody are interested in working together, and we have a special issue for 2027. We're looking for probably about 13 to 14 articles, and each kind of aspects of the food industry. So I'll end up here. Sorry for taking too much of your time. Thank you.
Thank you.